Okay. Hello, everyone, and again, welcome to our online interview series, which is titled as Shades of Green. In this interview series, the focus has been on sustainable approaches that have been adopted by various architects, various organizations, people who have been working with sustainable materials, with sustainable technologies, and various ways in which trying to find solutions to their practice or academics. So far, we have talked to four architects in this series, starting with architect Sankalpa, then architect Surya Kakani, Falguni Desai. Last Saturday, we had a very interesting interview with Sandeep Virmani from Hunarshala, and already there are various kinds of aspects that we have started discovering as we move along. And so there are various kinds of ways in which people are trying to address the issues related with sustainability ecology. So on one hand, we have people who are trying to work with alternative materials, alternative technologies, trying to work with socially relevant technologies which are dying. So there is this one department where people are trying to work with materials and technologies. On the other hand, there are efforts made in the direction of finding passive cooling technologies and finding thermal comfort through the means of passive cooling technologies. And that is also has been one of the approach that we have seen in many of the architects' cases. There is yet another approach in which, for example, in the last interview we had a word with Sandeep Bhai, and we could see the how through participatory design approaches they are trying to work with the communities. So it's interesting to see these various dimensions that through which various architects and organizations are trying to address the issues of environment in the field of architecture and design. Today we are going to talk to another architect from Indonesia. Very fascinating person, very fascinating practice. Someone who has been trying to find alternative to the burnt brick, and also trying to find its contemporary expression in his practice. Uh, Please join me in welcoming architect Andy Rahman from Indonesia. Andy, thank you so much and welcome to this interview series.
Thank you.
Yeah. Before I move ahead, please allow me to introduce Andy. Architect Andy Rahman established his practice in Indonesia in the year 2006. He has been doing works that include private residences, offices, hotels, rectorate buildings, school buildings, housing estates, homestays, boutiques, banks, schools, all kinds of housing, institutional, commercial projects which are spread across Indonesia. And it is really fascinating to see that in just the span of 14 years, starting from 2006, he has done more than 300 projects which are spread all over Indonesia. And it's going to be very fascinating to see his journey in this presentation. Uh, Please let me share the small text which he has shared with us about the presentation that he is going to give to us today. This conversation is about Andy Rahman's practice that has the spirit to restore the archipelago's craftsmanship and to modernize the archipelago architecture. The brick is one of the materials that has been used in architecture in Indonesia since 4th century. That's why he is spirited to learn more about how to conserve the material and also its craftsmanship. After finishing the Omah Boto project, he is going to reevaluate. He reevaluated the material, which is the burnt bricks, and its sustainability. And he realized that the red brick is not a very sustainable material. Red brick is damaging the soil surface and also increasing the carbon footprint. The talk today is going to take us through his journey of self reflection, where, on one hand, he attempts at preserving the brick architecture, fearing that the local brick craftsmanship might disappear. On the other hand, he talks about his research and trying to create sustainable alternatives to the burnt bricks through various handmade bricks in modern context, and that he does is using laterite soil and a whole lot of recycled materials that are found in Indonesia. Andy, this sounds for a very fascinating presentation. Can we please have your presentation?
Okay, thank you, Ayas. Um, I share my screen. Okay, my sound is clear.
Yes, yes, it's clear.
Okay, I'll start my presentation. Good morning, everyone. Assalamualaikum warahmatullahi wabarakatuh. I am Andy Rahman, the principal architect of Andy Rahman Architects in Surabaya, East Java. Uh, it's an honor for me to get invited to be a part of this series. Thank you so much, Archie Diaries, for this opportunity. This series is about shades of green, sustainable building approaches, and I will share about one thing, our local material that inspires me and gives big impacts on our design. That is brick, and in Indonesia language it's called bata or boto. Um, Two things that I'm going to present about our project story with bricks and our focus to develop the sustainable bricks. Uh, I will not claim bricks as a material belonging to Nusantara. Nusantara is archipelago uh, or Indonesia, my country, because the historical facts have provided knowledge that brick has been made and used in since the Neolithic period, 8,000 years ago. And after that, after Neolithic period, the wooden bauxite was discovered in Turkey. And as you can see, even in ancient Egypt, they can make brick in the unusual shape like a cone. Not only a cubical shapes or square, but a brick already have cell to be customized design from the start actually. This is a brick artifact that we was found in Indonesia, my country. Bricks have been exist since 4th century and mostly found in Java Island, in Sumatra, and even in Kalimantan. And mostly the artifact is in Majapahit Kingdom, is in the East Java. These are some bricks artifacts in Indonesia. This is Muara Takus Temple, Bahal Temple, Muara Jambi Temple in the Sumatra, and this is Batu Jaya in the West Java, Belahan Temple in the East Java, and Kali Bukbuk Temple in the Bali. This is in the 7th century. These bricks architectures have various style and proportion due to its various function. So this is since 4th century. And Mojokerto, you can see it. This is the location of Majapahit Kingdom site in East Java. It's just an hour from our office. This is our office in Sidoarjo or Surabaya. These are some of brick architecture from Majapahit Kingdom area and until now is still standing. Perahu Temple, it is the one of the highest brick temple in Indonesia. This is the Tikus Temple, it's like for bathing space. And this is Ringen Lawang, this is the gate of the Majapahit Kingdom. It's built in 14th century. Ringen Lawang Temple, this is the gate of the Majapahit Kingdom, and this is Perahu Temple, Bajang Ratu Temple, I'm sorry. And this is the tectonic of Jedong Temple. All of this is in Java. We can learn a lot from this whole temple in terms of proportion, scale, tectonics, details, materials, characteristics, etc. And we know at that time they could make architecture which have high mass, extraordinary and timeless. We have been researched and studied to the site until now. We always being curious and have many questions like how could they arrange the tectonics? Why did they make that form? And mostly amazed how agreed the bricks joins technique. And then we found what they used, what the technique our ancient built the temple with brick without cement. This technique is kosot bata. It's called kosot bata. Kosot bata techniques or rubbing brick technique. A technique of rubbing two bricks by giving them water, then left to dry. Brick powder and water react to the natural adhesive. After drying, one brick with another brick will stick, and this is strong. So in those days, our craftsmen built these temples without cement because it didn't use cement. The brick structure can be tight without gaps, as you can see. The results is very sophisticated. In our analysis, I found something interesting near our side project, Omah Boto. It is close to Pari Temple and Sumur Temple, which has very interesting tectonic bricks. These temples are located nearby and were built in the 14th century and never collapsed until now. It is also interesting because brick architecture with a spatial structure system can withstand earthquakes so well. This is the Pari Temple. And I try to come and witness the production of brick or red brick in the home industry. Because you want to know how bricks are made in Mojosari, East Java, where the Majapahit Kingdom place. There is one village where the entire population works as a brick maker. We observed the process and discussed with the craftsmen there. We try to understand as deep as possible of the brick characteristics from the making process. Then we explore it in our projects. Becomes the building DNA. This is the location map of Omah Boto, this one. And this temple of Pari Temple and Sumur Temple, and this is the capital city of Majapahit Kingdom. It's about 20 kilometers. We use MR8 brick from Mojosari Ham Industry in Omah Boto project. So MR8 is the initial of the craftsmen who designed this machine, press machine. The wife initial name Mufaroka, so MRH. When we research about this brick, there is something unique. That was MRH's brand name on it. This stem brand creates whole site around the MRH font that we can utilize it to hide the cement materials, so that with the tectonic design can be resembled like temples tectonics. MRH brick become the DNA of the whole house. The module size of the bricks determines all of these house elements dimensions. Even the doors, uh, height of space, fans, and others. So this is the reasons why this house is called Omah Boto or brick house, because brick as the genesis of this house. These are 13 brick tectonics applied in Omah Boto that inspired by Pari Temple and Sumur Temple, but with trying to modernize. This is the detailed drawing given the craftsman to help to arrangement process, how we communicate with the craftsman. They will understand the picture easily by looking at the colored code, like this, like this. This is the colored code. Position, section, kinds of installation, all of described in different colors. This is the decoding how to we communicate our idea to our craftsmen. And this is the result. The techniques of brick arrangement also embody some of Indonesia's batik pattern, and this is the owner's desire to make his house have strong Indonesian character. We can hide the cement in whole of the MRH brand on these bricks, so that the tectonics appearance is similar to the temple's tectonics, but is modern. Exposed bricks originality creates a unique view from its side of wall, floor, or even a ceiling. Along the process on sites, all knowledge is reciprocal. When the craftsmen meet some difficulties, they can communicate to us, and they can also give feedbacks and ideas that more efficient about the installation process. We, as a partners, we collaborate, and we become a team. This is the process, how they read the architectural drawing code, and they work with sense, with heart. We always try to explore the local material and give the value, and trying to give the challenge to our craftsmen. And that's nice because our craftsmen always answer our challenge with very good, simple technique, but the result is sophisticated. This is the other process, how they use iron because become the structure. They drew the brick. They can process this because our craftsmen understand the characteristic of the bricks as well. So the result is beyond the ordinary technique. And this is the result. This is the facade of Omah Boto. This similar with woven bamboo in our tradition, but this is a woven brick. The function is same. So when it night, the light is go through from the inside, but at day, The ambience inside is very nice. This is the tectonic in master bedroom. Modernize the batik pattern, Indonesian traditional pattern. And this is a space um, of bricks that able to transmit the sunlight and air ventilation into the building. So this is similar like woven bamboo, the principle. We are not only applying brick in the floor and wall, but also to try to use it vertically on the ceiling. And this is the garage backdrop wall was made out of residual bricks, so none of it went waste. From this building process, there are 10% of bricks waste, and that percent was arranged into the tectonic, and the results becomes the main point of view for this communal space. The remaining piece of bricks that have various sizes are collected in a place, then arranged to be an artwork. The client was very happy and sent me this picture when this garage as communal room used for communal Quran recitation activity that accommodate 100 people every 3 months before COVID. And that brick tectonics seems like a wall art. This is my client. This is my studio, our office. As you can see that we use bricks for floor, for ceiling, for wall. MRH brick for our other projects. Why we always use MRH or local bricks? Because I'm trying to preserve this type of brick that has been exist since 14th century. Because if we don't preserve it, the local brick craftsmen will disappear. They will be change the profession because there is no architect or people use the brick. I realized that red bricks has issue to become the part of destroying our earth and in its making process because it can damage of soil surface and causes carbon footprint. This research concludes that raw bricks is a good brick because it can absorb humidity so well, so that it fits perfectly with the tropical climate. So we are working on the two sides. First is preserve the burnt brick in Mojosari and increase its values. And other side, we should create the future brick, sustainable brick, trying to responsive the environment for the future. I began to explore, research, and try to create the sustainable bricks, earth-friendly type. The handmade bricks in modern context. You can call it non-fuel brick using the laterite soil, one of the great soils on our land, abundant material in our land in Indonesia. This is the process laterite soils forming. So it's laterite soil is a solution to issue for using non-fertile soil as building material in Indonesia. The characteristic of laterite soil is the natural red color. more higher iron oxide in it, get redder color. The texture is sturdy and dense. When it's freshly cut or dried, it has soft texture, but it becomes harder when it has directly exposed to the sun and air. This is the data that we have got. The laterite soil around the world is covering 30% of the land, mostly around to the equator like Indonesia, Africa, and India. This is the map of laterite soils, the oxysols type, the pink color, this one. This is the content type of laterite around the world, and Indonesia has the nickel ore laterite, uh, contains nickel ore. In India, many laterite soils were found in Kerala or Goa. This is in Goa, Kerala, side, in West Bengal, in Tamil Nadu. So last year, when I went to Kerala and had time to visit the Laurie Baker studio, which was also developing laterite bricks. So I think all of you must be familiar with this type of brick, or even just notice the soil. And last year, in our office, there is one student from Kerala, Puja Prakash, get internship in our studio for 6 months. He learned about how to make brick from laterite soil. Previously, the making process of laterite bricks was only cut into pieces because it has soft texture and allowed to harden than use. But in the long term, exposed to rain and heat, it eventually erodes. Laterite in Africa last year, unexpectedly, we received one student from Africa too. So not only from India, but in Africa too. His name is Golfa. He's from Mali, and he learned so lots of about technique to make laterite brick. And right now he sent me the picture of he has developed in Mali. I'm very glad. So in Africa, this material is very abundant, laterite soil. And this is maps of laterite soil in Indonesia. Some is in our place, East Java, and in West Java, in Sumatra, in Kalimantan, and in Sulawesi too, Borneo. One of the largest area is in Kalimantan, Borneo Island, which is have 50% nickel laterite on it, and the southern Sulawesi too. Well, this is what we have been doing in the at least 5 years. We think that we think as an architect or planner, we will not be able to develop without involving academic researchers and local craftsmen, because these three components always been supporting each other. I have collaboration with my Professor Toto from my colleagues who specialize in local material research, and we are going around to meet craftsmen who have the same vision on us. Then we have research of research pressed brick, the interlocking Lego brick, and developing the process. This is the making process of laterite Lego brick in non-burn brick and more sustainable. There is a unique about Lego bricks. We call it three-dimensional bricks. We can say this is the ordinary brick, two-dimensional, and Lego brick is three-dimensional. Meanwhile, Lego bricks are spatial bricks. We can explore it like applying Lego to create the tectonics. It's similar like applying Lego. And this is our project on progress with use laterite soil brick 100%. So we didn't use conventional brick anymore in this project. These are the process of designs and construction. This is the tectonic. Where did I get the inspiration about the Lego brick? And this is the answer. The interlocking system in Nusantara stone temples, discovery from the ruins of Borobudur temple and the Prambanan temple. It's really amazed me about all the ancient architecture that have treated the materials with great techniques, soil or even stone like this. Our ancient can build Borobudur temple and Prambanan temple. Our curiosity arose after seeing these temples details in Borobudur temples and in Prambanan temple in Yogyakarta, center of Java. That's why we have spirit to research the temples in how our ancient built both of temples without cement. And it turns out that's why we develop interlocking system. It because the techniques relate on the weight of the material itself. Borobudur, as you can see in the left, is the largest Buddhist temple in the world and has entered the 7 wonders of the world. And Prambanan temple is the first high-rise building in the Southeast Asia in the 7th century. These both temples were built by interlocking system without cement. That is what inspired us to make interlocking brick. In the interlocking stone techniques, it can overcome lateral force of earthquakes. So that we develop it, we add one element, the one feature. We give a hole, as you can see. We give hole in the brick for the iron and cement aggregate. So it can create a knot between vertical and horizontal force. So this Lego brick accommodates earthquake force. Is better than the interlocking system what our ancient developed. And this is the condition of Al-Fatah Mosque, still under construction right now. This mosque is 100% built by laterite soil brick. And we trying to explore the future brick. What is the future brick? We are trying to think on alternative materials that are able to face to the next challenge, which is developing from the basic material The basic materials are local soil, waste, and recycled materials. This is bricks from fly ash and bottom ash, waste from near on my place. We have got this coal burning waste from the power plants industry in East Java. And now the research going on to the Lego brick that use perlite. So the brick is from many types of material, from coarse plastic, from fly ash, from bottom ash, from perlite, even in the coarse of wood. We developed so many ways to become of material of this brick. We try to apply the fly ash and bottom ash brick in this project, Islamic boarding school in Probolinggo, because in this boarding complex nearby with power plant industry in Probolinggo, East Java, and it has so many ways of the coal. We have presented this project of Islamic boarding school to the director of the power plant industries, and that will be built from their waste material. And we show them the brick mock-up like this, our research. And they are really excited and agree to help to build this building. We held workshop in my office, to teach the people from Jombang to make brick from the local soil. So this project is most in Jombang, East Java. It's built from the local soil brick without burn. And we teach the people, the community, to make this brick and build this mouse by themselves. We held a workshop in our office to teach them, and when they have understood and succeed, they will come back to home, to this village, to teach to the others, and make the mosque by themselves. And this one my reason why we develop local soil brick. In Indonesia, as you can see this, this is one corner of an architecture exhibition in Indonesia that shows us many soil types which has been dug from all the province in Indonesia. Every site has its characters, so you can imagine how many types of brick that we can explore from all of place that we stood on. The uniqueness, the sustainable materials, the characteristics make it by low footprint to big impact on our design and environment. So this bricks is solve two problems. So one is local materials, and two is benefits. And even this soil can be involve the people, not only craftsmen, but ordinary people can make these bricks, and this is very, very sustainable brick. This is our project where in the other city we designed custom brick in this project. the tectonic. We're trying to make like parametric approach for this project. So the brick, we cannot use the ordinary brick. We should make a customized brick. That brick was made of waste materials, the shards of tiles, the disposal of waste of terracotta, like tiles, bricks, earthenware, um, a roof like that. This is waste in the process, in the making process. So and in Plaret, in Purwakarta, is a city of terracotta. So there is so many ham industry there to produce these terracotta materials, and when the making process always have maybe 20% waste, and this they throw to everywhere like this. So we're trying to collaborate with the local craftsmen there to make the waste or uh, this waste to become new material. So like this one, brick customized. Sometimes we create fan block from this material. So we're trying to involve the local craftsmen to make customized brick from recycled bricks, and this is very sustainable. And this is our study in our studio. We make mock-up with our staff and our craftsmen before we applied this tectonics in our projects. We always try to make and develop various types of bricks, the custom bricks that depend on of the project's context, collaborate with the local craftsmen to make sustainable materials. So these bricks, many types of bricks, we have products with our partner, local craftsmen. Then from so many types of waste and local soil, because we have like a principle, we're trying to develop architecture from the DNA or the cell, and the cell is brick itself. um, at least, and at least but not least, there will be many new possibilities in architecture, because architecture is designed from the cell like this. This one the example of in our project. When we make brick with trapezoid shape, we will get a lot of new possibilities and a lot of expression of our architecture, which we can get it when we use square brick or conventional brick. So we only make simple things. The square bricks we cut in the two sides become trapezoid shape. And if when we study in the mock-up with our staff in studio, the result is so many possibilities like this, and this is cannot be reached when we use only square brick. And I think that's what can I share today. I hope all of you can take a good thing from my presentation, and thank you so much for.
Yeah. Thank you so much, Andy. It was a very, very fascinating journey. It was a very fascinating presentation. Uh, and to see your struggle, essentially, it is a struggle to find you. On one hand, you want to preserve the craftsmanship that is existing, that works with the brick. On the other hand, we cannot go ahead and use the same burnt bricks because of the issues that it has in terms of the soil and the energy that it consumes. So, on one hand, we are trying to preserve the craftsmanship, and on the other hand, the idea is to find as many better alternatives for burnt bricks through using, let's say, local soils or various other waste materials. So that was really a fascinating journey. What when you started this presentation and you showed some of the brick temples from the Majapahit kingdom, and there are a lot of similarities that we have been talking about when we compare it with the Indian context, and particularly one thing that I would like to share is with the region of Bengal. You know, if you look at the Bengal temple architecture, it's very much similar to what you have shown. The kind of brick temples that you have shown is the even the time period is more or less, is similar, and the expression, the technique, and even, in Bengal they call it Bengal deuls. So these were square little temples which are extruded with a shikhar on top, and essentially with the technique of corbelling, no arches, they made these temples, and it's very fascinating to see the parallels with the temples that you have shown. Now, when I come back to your presentation, I there are two things that I take away from this, and I'm trying to understand your struggle, your process. I'm just trying to understand. So on one hand, uh, we are trying to, let's say, find sustainable solutions of for the brick and other materials, and on the other hand, there is also a struggle to find a contemporary expression which is, let's say, rooted in the architecture, rooted in the place, which is in what makes Indonesia. Okay, so you are also trying to study how, not only how the temples were built, but also how the articulation was done in those temples. Not only you are trying to understand the tectonics from those temples, but you are also trying to understand certain qualities, certain ways, certain patterns which were there, and then you are trying to find a modern expression of that thing. So I find these two things going parallelly in your project. Would you agree with that?
Yes, correct. I'm
So
agree with that.
yeah. No, when I look at the material part, when I look at your project, when I look at your Omah Boto project, and even other project that you showed, so there are two kinds of expression that I see. On one hand, two ways in which brick have been used. On one hand, the brick has been used as a layer that comes onto the wall and gives a meaning to the space through different patterns that you take inspiration from the classical architecture of Indonesia. And on the other hand, you are trying to work out these screens out of brick. Okay. Uh, Now, are there, so, and I find these are two different ways in which you are trying to experiment with the brick. Of course, so the brick which comes as on top of something, maybe on top of the flooring, on top of the wall, below the ceiling, that's one exploration. And on the other hand, you're trying to find different ways through which you can make screens, you can make jalis, just like the way in Laurie Baker's architecture, he was trying to make use brick and find various ways through which he could make these screens. Uh, are there any vernacular, the build forms from which you take this inspiration? Because the screen part is not something that is there in in the temples. It's something that is probably is getting reflected more in the local vernacular architecture of the Indonesia. So how does that come into this?
Nice question. Yes, correct. So actually, I'm not only trying to research the temple, but we're trying to research the Nusantara architecture or traditional houses in Indonesia, in spread all of around Indonesia, and we got so many insights. One of that is how our ancient uh, built the house, especially the wall. So because our climate, characteristic climate is tropical, humid and hot. So the best way to build or make the wall is like breathing wall like that. So mostly our ancient use woven bamboo, or some is rattan, and sometimes they use wood. But the wood have like space to get through the light or sunlights and the air, the circulation air. So we inspired from that techniques because we, according to me, that's very good for tropical climate as a solution. So that's why we develop it to our approaches design. We make secondary skin. Mostly our architecture is have secondary skins because actually secondary skins, the principle is similar with woven bamboo in our traditional houses. So that's the reason.
Yeah. So this screen part of it is something that comes from the vernacular architecture, where and like you said, when you look at the vernacular architecture of the equatorial climate, essentially it is an equatorial climate. The place where you are in, it's very much similar to, let's say, Kerala, Goa, but very heavy rainfall. I guess it must be nothing less than 2,000 millimeters per year annual total rainfall. Uh, and because in this equatorial climate, the cross circulation is one of the most important part when you want to achieve thermal comfort. So then the use of the screen becomes very important, and that is how Laurie Baker also what something that he explored in his architecture. One thing which you said is that in the traditional architecture, the vernacular architecture of the Nusantara, there is a usage of bamboo, and sometimes the timber has been used to make the frames out of it. So it is essentially a frame structure, right? And then the infill has various kinds of rattan and all kinds of screens traditionally that they use. So when I come back to your architecture, that timber and bamboo is now, let's say, getting replaced with a concrete frame, right? And the infill, which was, let's say, some other material, bamboo or something, is now, let's say, getting replaced with various kinds of brick skins. uh, is that Would you agree with that?
Um, Actually, in our design, it's not only develop the bricks. We develop bamboo to timber too. But today, I only present my project special with bricks. So what you say is correct.
Yeah. Yeah. So, with that, I think I have another question. Since we are talking about the in most of the, maybe there are, I mean, you've been doing more than 300 projects already, and there are various kinds of projects that you have been doing, various typologies that you have been doing. But like in today's and even when I look at your traditional architecture, it is by and large the frames, and frames which have been elevated, so and that is also what I found in your architecture also. Is it that the soil is not suitable for load bearing explorations, and because of
No,
that?
actually, why our ancient is built the house hanging from the ground. Actually, is the answer of our climate too. So because in we have so many rains, as you like what you say. So when in the rainy season, our land or soil is wet. That's why our traditional house is hanging. Uh, Maybe they 1.2 or 1.8 like that. So actually, that's the answer of the climate too. Yes.
Yes,
In my project, several of our project is do it that too. Several of boarding house and houses. We're trying to not build the house landed, but hanging from the ground.
yeah. I'll come back to the brick, that the explorations that you have been doing with various materials, and so on one hand we have the burnt bricks, that's on one side. On the other side, there is a brick that you have been making with the laterite soil, so which are essentially compressed blocks. So, what kind of binders do you use in making these uh, pressed blocks, the laterite
We
bricks?
use cement. We use
There,
cement, but only 5%. The composition only 5%.
so there is 5 to 10% of the cement is added in the dry mixture.
Yes, yes, that's
Yeah.
right.
So that's one part of it. And on the other hand, you in the last project that you showed, which was the Islamic boarding school, said that you've been using fly ash bricks. You've been trying to use that. Now, fly ash is a kind of a pozzolanic material which requires the presence of lime, you know, in order to activate itself and create some cementing properties. So have you been using also been using lime in the along with this fly ash bricks that you've been using?
Um, it depends in the research. So if in our we're trying to research the composition for make a better composition for fly as brick. And we found a fly as brick. What we research is didn't need lime for the composition. It's only cement and the fly as itself. It's several soils. We need calcium like that for the composition, not only cement. But uh, it depends the characteristics of the soil on waste like that. So it's need research before we found the best composition for every each brick from depending the material of the waste.
Yeah. Yeah. So you've been using cement along with fly ash in these cases as
Yes, yes,
okay.
yeah.
Yeah. So yeah, I mean the kind of explorations that you have been doing is fantastic, and particularly the last slide that you showed, that exhibition and the range of the soil, that is
Yeah,
local soil. I think to me that was the kind of summary of your entire presentation. You know
yeah,
that yes, we started with burnt brick. We came to
yeah.
laterite brick. Now we have the future brick, and the future is endless. Actually, the kind of permutable
Yes. Okay.
combinations you can have
Yeah.
is
Yes.
there is no end to that thing. So
Yes. Yes.
that has been fantastic journey to see. One last question that I have. Uh, you also said that there is a workshop, that is right next to your office, and you like
Yeah.
to keep experimenting with material. You like to keep working with the craftsman, and there's a triangular relationship that you showed, in which the craftsman is a very important, part of this whole process. uh, how do you see your practice in there's a role of the architect also at the top, so there is a research part, there is a craftsman part, and then there is an architect, which is you. So how do you see yourself placed in that triangle?
I think my position is similar with the others. So I'm not the important one. So we're trying to collaborate. So all of us is important, same important, because we feel every part of the what this means like because actually architect cannot be work with high grade or if we take our position in the highest. So actually, what we do in the our practical is we are same with our craftsmen. So that's why reciprocal uh, can be happen. So I think I'm not agree if architect is the most important position like that. So I think Indian architects doing the same with me. We collaborate with so many discipline, craftsmen, researchers, or some in ordinary people like that. So to build the good architecture, because I think architecture is should be um, reality, should be with or with community or not for um, a segment or only for rich people, but architecture should be rich all of the human, even in environment and anything like that. So actually that's what my side of, or my perspective.
Yeah, it's
That's,
really humbling to know that thing. And the way I understand is that in that triangular diagram that you showed, so there is an architect, there is a craftsman, and then there is a research and development part. So someone, you said you're also trying to associate with, let's say, a professor who knows the local resources, who has a knowledge of
yeah,
local resources. So there is a value to that research. Then there is a value to the practical knowledge and the skills that the craftsmen have, and the architectural practice, which is you. It becomes a kind of a platform where all of us, they come together to find the contemporary solutions. I think that's the architectural practice in a way becomes, a kind of a platform where all of these can come together and interact amongst themselves. So I think that sounds a really an interesting mode of practice, and it was really fascinating to see that there is a workshop that is attached right next to your uh, uh, practice, which means that you value the role of the craftsman in your practice, the role of the hands-on experimentation. is something that is valued by the practice. Uh, Andy, it was a really a fascinating presentation. The discussions was also very nice, and I'm really thankful to you for agreeing to come for this interview series. Uh,
Yeah, welcome.
and we really look forward to some future collaborations as well. Thank you, Andy.
Yeah,
Yeah,
maybe I can give one more,
please.
if you don't mind. Actually, we have platform for teaching students around Indonesia. That platform is Padepokan Cap Tukang, and every month we held, because of before COVID, every month we held like workshop to make anything, make like local soil brick without burn, laterite workshop. We will make laterite bricks, and sometimes we open workshop for tectonics, for anything, to every project of our project, and in the field. So, and the tutor of the teacher is our craftsman. That's what we have done in our practice. So we are not only work, but we trying to make platform for teach students around Indonesia to revive the craftsmanship and local material things. I think that's all. Thank you. You have invited me in this very good opportunity for me, and I hope there are good things that audience can take from my presentation.
Sure, sure. Thank you. Welcome, Andy.
Yeah.
I would like to conclude here with the note that the next our series will continue, and the next Saturday we are going to talk to a practice from a very different region altogether. We're going to talk to a practice which is called as Equipo de Arquitectura. They are based in Uruguay, and they have been exploring on similar lines with the sustainable materials, techniques, and also the resources. And I welcome you all, and I hope to see you back next Saturday. Just one change in the timing will be that the next Saturday we will be having our interview at 7 o'clock. It's as per Indian Standard Time because of the practice is based in Uruguay, so that will be their morning time. So I hope to see you all in that interview next Saturday, 7 o'clock in the evening in IST. Thank you so much.